Welcome everyone to today's lesson on digital logic design, lesson 5, truth tables. Just before we start, I would like to remind everybody to like, share, and subscribe. I recommend Complainer studies to your friends, your loved ones, people who you know are struggling with the subject. It's a very engaging YouTube channel to watch. You'll get a lot of good information and good insights from it. Let's go into today's lesson on truth tables, lesson 5. And Let's start first with what a truth table is. So a truth table has variables listed with their possible values and outcomes. So A and B are variables, right? As we have already seen in our previous lessons. And These are the possible combinations, these are the possible values of A and B. Because A can be 0 and B can be 0. A can be 0 and B can be 1. A can be 1, B can be 0, and A can be 0 and B can be 1. So these are all the possible combinations of values for A and B. So how do we get here? How do we get the possible combinations for A and B? Let's see that quickly. To do that, you have to analyze A and B. So there's a quick formula for that, and it is that if you want to get the number of possible combinations for a set of any amount of variables, let's say 2 variables, 3 variables, 4 variables, the number of possible combinations is equal to 2 number of all possible combinations is equal to 2 raised to the power of the number of variables. 2 raised to the power of the number of variables gives you the number of combinations. So in our scenario here, in our case here, we've got 2 variables, A and B, 1, 2. So that gives us 2 variables. And what is the number of combinations for this setup? The number of combinations is 2 raised to the power of 2. This 2 here is your number of variables. You have 2 variables. While this 2 is part of the formula, this one is actually part of the formula. It's constant. So 2 to the power 2 is equal to 4. So 4 possible combinations. So this should give you an idea that, oh, I have 4 possible combinations that I can get from these 2 values. So now, how do we get these combinations? We know the number, yes, but how do we get these combinations? So what you do is that you look at your first variable column here. You need 4 possible outcomes, right? So you divide the number of possible outcomes by 2. You have 4 possible outcomes, yes, but divide it by 2, as in go halfway, half of that, and that's 2. So this tells you that you should have 2 zeros. You should have 2 zeros first, 1, 2, 2 zeros and 2 ones, as in half of the A column should be zeros and the first half zeros, the second half ones. You always start with 0. So the first half is 0, 0, the second half is 1, 1. Then for the B column, your variable 2 column, you divide the number of possible outcomes 4 by 4 this time around, as in quarter. You go after half, you go to quarter. So by 4, and that gives you 1. That means you should change from 0 to 1 and then from 0 to 1 again. So from 0, that's 1, 0, 1, 1, 1, 0 again, and 1, 1. So that gives you a pattern there. 0, 0, 1, 1 for A and 0, 1, 0, 1 for B. And that's it. You've gotten the set of all possible combinations for A and B. So that's how you do it. Then if we had 3 variables, A, B, and C, 3 variables this time around, 3 variables A, B, and C, how do we do it? 1, 2, 3. So the formula is 2 to power 3. 2 to power 3. This is the number of variables, 3 variables. 2 to power 3 is equal to 8. So you've got 8 possible combinations. 8 possible combinations. And how do we then get these combinations? You start first with 8. You got to start first with 8, and you start first with 8. So A is equal to, so for A, for the A column, it's going to be 8 divided by 2, which is 4. 8 divided by 2, 4, as in go halfway. So that 4 tells you that you're going to write 4 zeros and 4 ones. So 4 zeros first, 1, 2, 3, 4. 4 zeros, 1, 2, 3, 4 zeros. At half point, you then switch to 1. 4 ones, 1, 2, 3, 4. 4 ones. Then what about for B? For B, you're going to go quarter. So divided by 4 then. Divide 8 by 4, you get 2. That means your sequence is 2 now. 2 zeros, 2 ones. 2 zeros, 2 ones. 2 zeros, 2 ones. That's the sequence. 2 zeros, 2 ones, 2 zeros, 2 ones. And that gives you the B column. Then for the C column, you divide it by 8. As in, we're going 1 over 8 now. You know, 1 over 8 is half of a quarter. Half of a quarter. Half of a quarter. As in 1 over 2. 1 over 2 times 1 over 4, which is 1 over 8. So we're going half of a quarter now, and that's how you get 8 divided by 8. That's 1. So it therefore means that C should alternate. C should alternate 0, 1, 0, 1, 0, 1, 0, 1. So 1, 0, 1, 1, 1, 0, and then 1, a 0, and a 1, a 0, and a 1. And once you do this, you get the set of all possible outcomes. The set of all possible outcomes, the combinations for these 3 variables. So that's very easy. Remember the formula, 2 to the power of the number of variables. So if I have 4 variables, if I've got four variables, it means that my number of possible outcomes would be 2 to the power 4, which is 16. That's if I had A, B, C, and D. A, B, C, and 4 variables. So 2 to the power 4 is 16. So you will be doing 16 divided by 2, 16 divided by 4, 16 divided by 8, and 16 divided by 16. Just the same way we've been doing it. This is for A, for B, C, D. So it's a very simple procedure to use. So now that we know that, let's analyze our truth table. So in this truth table, we have our output. These are the inputs. Listed. The inputs are listed, and the outputs are also listed. The outputs are P and Q, and P and Q have been defined here. We see that P is equal to A or B. P is A or B, and Q is A and B. So let's get the values for P now. Since P is A or B, so 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, and 1 or 1 is 1. Remember, in our previous lesson, we established that the OR gives you an output of 1 only if any of the input values is 1. So you have to have at least one input value that is 1. So here we have a 1, here we have a 1, and here we have a 1. That's why we have an output of 1 for OR. But in the first case, where we had no 1 value, no true value, we got a false. Now, for Q is equal to A and B, what's the condition there? We need all your input values to be 1. If you have one input value that is 0, then you're getting a 0, a false. So everything must be 1. Everything must be true. So in the first condition, 0, 0, you don't have any true value there. So of course you're going to get a 0. 0, 1, you have no true value. You have a no true value for A and a true value for B. So that's 0, 1, and that gives you 0. because not all your input values are 1. You've got 1 0 next, and that's not fulfilling what we had established, because we need all to be 1. So 0 again, and now 1 1. Yes, that's what we want. All your input values must be 1, and that gives us an output of 1. So let's proceed. This is a very short truth table because it's a truth table for complements. For complements, we only have one variable here, a. We have one variable, a, and according to our formula, according to the formula we've established, we said that the number of combinations is equal to what? 2 to the power of the number of variables. In this case, I have just one variable, a. We had only a on that truth table, so 2 to the power 1 is equal to 2, is equal to 2. So 2 possible combinations, only 2 possible combinations. That means 2 rows, two horizontal rows, and that's exactly what we see in that truth table at the top. Just 2 horizontal rows, 2 possible combinations for just one variable, and to get the sequence, we just need to divide 2 by 2, which is 1. So that tells it just 0 1, right? 0 1, 0 1, because the half point of 2 is 1, right? So just 0 1, and that's exactly what we see there, 0 1. So let's analyze this truth table. We have P, which is equal to a complement. A complement. The complement only needs one variable, a. So 0, the complement of 0 is 1. Complement negation changes the value of the variable. So if a is 0, it's going to change to 1. And if a is 1, it's going to change to 0. So that's what's happening here. And then in this truth table, we have a and b. But then we look at the output. The output is Q is equal to A exclusive or B. Exclusive or was covered in the previous lesson. So A exclusive or B. And we've generated a set. The set of all combinations is the same as our previous. It's actually the same as our previous truth table. It's the same here. So no need to explain that. We know how we get here. So how do we get the outputs? Remember, exclusive OR gives you an output of 1 only if the number of true values, the number of ones in your input is odd. If it's not odd, then it will give you a value of 0. So in the first case, where we don't have any true value, where we don't have any 1 in any input, it's going to give us an output of 0. The second case, we have one true value. There's only one true value, and 1 is odd. So since 1 is odd, our output is 1, true. The second case, 1 0, A is 1, B is 0. It's still one true value, and that means it's odd. So the output is 1 also. And in the fourth case, where we have 1 1, we see that we have 2 true values, and that's even. 2 is even, so it's not odd, and that's how we get 0. So this is a truth table, set of all possible input values and the output values for each case, the output value for each case. They are very useful. Truth tables are very useful. So let's see where truth tables are used. So the perfect induction method, it is used to prove Boolean laws. We'll be covering Boolean laws in our next lesson. We're going to use it actually in the next lecture to analyze Boolean laws. So it's used to prove these laws, and it makes use of a truth table. So we're going to cover 2 examples here. Example 1, use the perfect induction method to prove that P and Q complement is equal to P complement or Q complement. This means that the output you will get from P and Q complement should be the same as the output you will get from P complement or Q complement. So let's dive right in. Let's see how we use a truth table to prove that. So we first of all look at how many input variables you have. How many variables you have in the entire statement? Let's count. P, Q. P complement is just a complement of P. So we still need P, and then we have to find the complement, the negation of P. So it's still P, and then Q complement, it's still Q, but just the complement of Q. So we only have two variables, and it's obvious really because we only have two letters here, two letters of the alphabet, P and Q, two variables. And since we have two variables, we have 2 to the power of 2. That the power there is the number of variables, the 2, the power, the number of variables. So we have 4 possible combinations, and for P is going to alternate between 0 and 1 at a half point. At the half point, the first variable will always change at the half point. So 0, 0, 1, 1. The first half is all zeros, the second half is all ones. For Q, the first quarter is 0, the second quarter is 1. The third quarter is 0, the fourth quarter is 1. It's a sequence, so 0, 1, 0, 1. And you have the set of all possible outcomes here. So let's look at the left-hand side. We look at the left-hand side and we see P and Q complement. So before we get P and Q complement, we need P and Q. So what's P and Q here? 0 and 0 is 0. 0 and 0 is 0. 0 and 1 is 0. So remember, AND needs you to have all your input values being 1. And since P here is 0 in both cases, it means that P and Q is going to be 0 because P disqualifies it. P ruins it for the AND here because it's 0 at the top. It's 0 here, 0 here, 0, 0. So it's already been, you don't really need to check Q because you know that the output is already going to be 0. So for the bottom two, P is now 1. Okay, fine. P is 1. Now the question is Q also 1 so that we can get an output value of 1? Is Q also 1? And we see that here Q is 0. So no. Even though P is 1, Q is 0. So we have an output of 0. And here P is 1 and Q is 1. 1 and 1, we have an output of 1. So we have P and Q. So P and Q complement is just the opposite of P and Q. So since P and Q is 0, 0, 0, 1, P and Q complement will be 1, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, the opposite. So this brings us to the end of the left, of the left-hand side, the left-hand side. That's the end of that. So we now need to consider the right-hand side where we have P complement or Q complement. So we need the complement of P, obviously, before we can execute this. So we go ahead and find the complement of P. So P is 0, 0, 1, 1 means P complement obviously has to be 1, 1, 0, 0, 1, 1, 0, 0, the opposite of the P column. And then the Q complement column. What's my Q complement column? I look at my Q column, it's 0, 1, 0, 1. So my Q complement column has to be 1, 1, 0, 1, 0, 1, 0, 1, 0, the opposite. Now I have P complement and Q complement. I can easily compute P complement or Q complement. So how do I do this? I use the knowledge of the OR operation, the OR logical operator from our previous lesson, from lesson 4. I know that OR is only going to give me an output of 1 if any of my input values is 1. So if any of them is 1, then the output will be 1. So here P complement is 1. I know that the output is going to be 1 already without necessarily checking Q complement because it's if any. So long as P complement is 1, I'm going to get an output of 1 without necessarily knowing what Q complement is, because 1 or 1 is 1 and 1 or 0 is 1. So you just need one true value there. Just need one true value. So here P complement is 0. Okay. So now what's Q complement? Q complement here is 1. So I just need one true value. And I have it here. So my output is 1. And here 0 or 0. I have no true value at all. The output is 0. So now, how do we then know? How do we use the perfect induction method to prove? After having the table, how do we use it? So we have to look at the two columns here, P and Q complement and P complement or Q complement. Are they the same? So 1, 1, 1, 0 and 1, 1, 1, 0. Would you look at that? Both of them are actually the same, 1, 1, 1, 0. So It therefore means that P and Q complement is equal to P complement or Q complement. It's as easy as that. So let's get used to it by solving another example. Example 2, use the perfect induction method to prove A and B complement A and B. The complement here is on B. The complement belongs to B. A and B complement in a bracket, meaning do A and B complement first and use that answer, or B is equal to A or B. So let's get into it. How many variables do we have here? We have two variables again because we only have A and B in the entire expression. So A and B, we know how to generate a set of all possible combinations already. So let's jump right into B complement. What's B complement? The opposite of my B column. 1 0 1 0. The opposite of 0 1 0 1. So what's A and B complement? Here A is 0, so 0 and anything would be 0 automatically. It's going to be 0 because 0 and 1 is 0, and 0 and 0 is 0. So 1 and 0, 1 and 0 is 0. So we see that 1 and 1 is 1 there. Yeah, 1 and 1 is 1, not 1 and 0. 1 and 1 is 1, and that 1 and 0 is 0. 1 and 0 is 0. So we know A and B complement now. So we can now do A and B complement or B. So what's A and B complement or B? So I have to do this or this here. So 0 or 0 is 0. 0 or 1 is 1. Yeah. 1 or 0 is 1, and 0 or 1 is 1. So far as I had a 1, I always had a 1. Only in the first case that I didn't get a 1, that I had a 0. There was no 1, no true value, so there was a false value. So what's A or B? A or B, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, and 1 or 1 is 1. So since these two columns are the same, since these two columns here are the same, it means that that this expression is true. And hence we've used the perfect induction method to prove this Boolean statement, this Boolean expression. So we'll be seeing more on stuff like this in our next lesson. So hope you enjoyed today's lesson. If you did, I encourage you to like, share, and subscribe. I encourage you to share this channel with your friends, those you know who are struggling with the subject. Share it with them. The comment section is always available as usual, where you can drop your comments, drop your questions based on the video. Anything you don't understand, you can always ask in the comment section. So that brings us to the end of today's of the lesson. Hope to see you in the next one.